Welcome you all to the Management Science course unit offered by the Department of Commerce, Faculty of Management Studies and Commerce, University of Srijardhanapura. So, up to now, we have discussed with you relating to the management science uh, courses, that means sessions. We started with the management science introduction. Then you identify why we need to know about the management science and what is management science, first of all, and then the its advantages and disadvantages based on these models and scope of the management science and its applications, etc. So then session number 2, we discuss about the most important part in the management science, that is linear programming. So we understanding about what is a linear programming, why we need to develop linear programming, right? Why linear programming identify as an important concept coming under the management science. So under the linear programming, first of all, we discuss about how to develop the model, right? We know that in a management science, the mathematical model is a foundation. So then we understanding about the way of developing that mathematical model, right? So in this sense, we discuss about the objective function, alternatives, constraints, non-negativity constraints, right? And then based on that, we develop the uh, management science mathematical models coming under the linear programming. Then under the linear programming also we discuss with you how to solve it, right? So we know that in management science there are two solutions. One is optimal solution and other one is a feasible solution, right? So normally we need to find out the optimal solution. We first deal with the feasible solution and then we are coming across with the identify the optimal solution. So in a linear programming or mathematical models, we can solve linear programming model in two ways. Or either we can use graphical method or else we can use with the simplex method, right? Now both methods you are familiarized with and how to deal with the graphical method, graphical approach, that if you have only two decision variables, you can use graphical method. But if you have more than two decision variables, you have to work out with a simplex method. And based on the practical sessions, what we have conducted with you, we discuss with you how to deal with the Microsoft Excel solver and find out the optimal solution. Then we make some another step forward and we discuss with you regarding sensitivity analysis, right? That means if there are any changes of the objective coefficient or resource constraint, what will happen to your optimal solution, right? That session also we discuss coming under the practical component, and we teach you how to get the sensitivity report using Microsoft Excel solver technique. Right now you have lay a foundation regarding linear programming and way of solving it, and now you know something. Now you know you have a better understanding about the management science concept, right? So linear programming model, actually we discuss about some decision making regarding production, the decision making regarding marketing, decision making regarding resource allocation, etc., right? So today's session, session number 6, we are moving to another step. Actually, session number 6, first part, we discussing about transportation model, right? So under the transportation model, we know that whatever we are producing in our manufacturing plant or in our factories, so wherever the places, okay, warehouse or something else, we have to transport it. We have to disseminate that production or distribute that production to the marketplaces, right? So that's why in a linear program, sorry, in a management science, we have to work out with the transportation model. Okay, so actually under the transportation model, what we discuss is, in here we try to module the routing plan or distribution plan of the organization or a firm who are producing some product and who are expecting to deliver to the market, right? and we are expecting to finalize, or we are expecting to come across the most optimal routing plan where that organization can distribute their production into the desired market. Okay, so normally if we go through this is as a warehouse, right? We consider it as a warehouse, right? And this is your market, right? This is your market. If you have only one warehouse and only one market, you don't have any issue. But assuming that you have several warehouses, like you have several assemble points, now this is warehouse 1, this is warehouse 2, and you might have warehouse 3, right? Or something like that, right? If you have several warehouses, as well as if you have several markets, right? This is market 1, this is market 2, and this is market 3, right? If you have this kind of situation, now you are in a decision making points, in which warehouse product going to be which market, right? Whether warehouse 1 going to the market 1, whether warehouse 1 going to the market 2 or market 3. Oh, this is going to be market 1, or warehouse 2 going for the market 2, and warehouse 3 going for the market 3, right? Likewise, you have to make the decision, right? So the management science, we give you some opportunity to dealing with this kind of decision making process by calculating this, or by constructing transportation model, right? The assignment model we will discuss later. Today we are focusing on transportation model. Actually, what we discussing under the transportation model is we try to module the routing plan or distribution plan of the organization, where it producing somewhere else and sell it to the several markets, right? So then today we discussing coming under session number 6, transportation model. And in here, as usual, you have to refer the recommended textbook chapter 5 for more detail, right? I'm always telling you this because you have to prepare your own note. You have to work out with the extra exercises appears in your recommended textbook with the relevant chapter. So please refer chapter number 5 in your recommended textbook. Okay, right. Moving on, let's see what is the transportation model. Now you can see the similar thing I discussed with you. Okay, so objective of the model is to minimize the total transportation cost while satisfying all the supply and demand restriction. Now previous case, I just explained you only this, right? Now assuming this is your warehouse, right? Now sources mean where you producing your products, right? And destination is your market, right? My previous example. Right now you have three warehouses and you have 3 markets. Now you need to make a decision from which warehouse we have to fulfill which market demand, right? From which warehouse we have to fulfill this market demand, right? Normally this your warehouse, we call it as your supply source, right? That is your supply, right? So market mean where your demand arising. That mean where the demand making on, right? So under the transportation model, we try to develop a module, or we try to develop a routing plan where we can fulfill our demand and supply, or where we can fulfill our demand based on what we have in our warehouse supply at minimum transportation cost. Please remember this point, right? It is not necessary. We can fulfill in market demand through our warehouses supply. But remember, management science always dealing with what? Management science always dealing with optimal decision. Don't forget about that condition, right? We always dealing with optimal decision. Right? I'm really sorry about my handwriting because it's very difficult to write from these drawings. Okay. Right. So management science, we know basically is a foundation of identifying the optimal decision, right? So we can supply our sources from our sources to fulfilling the market demand, but we have to take the decision based on how to fulfill the market demand using our existing supply with this minimum cost of transportation. right? Otherwise, you first starting from this source one, that means your warehouse one, try to fulfill all the 3 marketplaces, and then again 3, you try to distribute all 3 markets, right? Likewise, you can do it, but until finally, when you are calculating your total production cost, you are getting highest production cost, including this kind of unbearable transportation cost, right? Therefore, we are developing this management science to find out the most effective distribution process or distribution channel where we can fulfilling or satisfying our supply and demand using in order to minimize the total transportation cost, right? So that is a basic concept coming under the transportation model. Okay, right. Moving on, we discuss in this example, right? So specifically, when the transportation model, or we call transportation problem, first of all, we need to create that transportation problem into transportation tableau. Okay, normally that's the process we are dealing with in the transportation problem or transportation module, right? First of all, actually, now we have a transportation problem. No, what is the problem? We need to fulfill our market demand using our sources of warehouses at a minimum transportation cost. So then normally transportation cost come in as a minimization problem, right? Normally we are developing the linear programming in here, right? So in your objective function is miniset, right? Normally if you are deriving objective function for this, then your objective function getting miniset. Okay, so then that transportation problem, I write it as a 3B transportation problem, you have to converting as a transportation tableau, right? Actually, we are creating this transportation problem into the model. That model we call transportation tableau. Okay, this is some kind of similar to your linear programming, but in linear programming we are having functions, no? But in the transportation problem we are having a tableau, actually a table, right? Now let's look at this example, then you understand what I'm saying. Okay, now in this particular example I'm extracted from your recommended textbook. Okay, so there are 3 warehouses, that mean workstations, or we call factories, and its production capacity you are given. Okay, now each warehouses there are different production capacity, right? For an example, Los Angeles warehouse, it can produce 1,000 cars, right? So otherwise others they can produce 1,500 and 1,200 respectively. Okay, so there are 2 markets in this particular organization or firm. They are having 3 working station or workstation, and they try to fulfilling the market demand based on 2 marketplace, right? Then this is your supply, and this is your demand. Okay, right. Now we are producing this much of thing, assuming that this is for the monthly production, right? And for the monthly demand, we are having this monthly demand from different market. Okay, right. Now what is the other point of the information we need to know? Other point of most valued information is we need to calculate transportation cost from each warehouse or each workstation to each market. Right now, for an example, how much we have to bear as a transportation cost if we try to deliver our produced car to the market called Denver, right? That means the Los Angeles market producing 1,000 cars and Denver market require 2,000 to 300 cars, right? If you try to fulfill in this market demand by using this workstation supply, right? What will be the cost of transportation at one transportation route, right? Okay, that means this 10,000 cars, how much it will cost to fulfilling this demand out of this 2,300. Okay, so normally that calculation we need to know. That calculation we have to work it out before we are making with that module. Okay, now in your textbook it clearly says, right? If you can't see it very properly, you please refer the textbook detail, right? Now it says from the Los Angeles to Denver, for the one route, that means for the one delivery or first delivery, it take $80, $80, right? From one transportation unit to Los Angeles to Denver, it cost $80, right? Similarly, from Los Angeles to Miami, it cost $250. Right now, you can see that cost become different because the destination length are differences, right? So then Miami, it getting more cost for the transportation, right? Then Detroit, it producing 1,500 cars, and in order to provide Denver market requirement, it cost $100, right? And for the Miami, it cost $108. Likewise, you are getting the transportation cost we have to incur from one workstation to one marketplace at a one time, right? This is for one route, one delivery route. Okay. So now the question is, how much we have to incur this, as much of this transportation cost when we are trying to fulfill in this market demand. Right now we have 2,300 cars demand at the market called Denver, right? So assuming that if we try to fulfill him by using Los Angeles and Detroit, right, then we have 2,500 cars, right? But if we are using these two, we can fulfill in this car, right? But we have don't forget, we have to come across with the transportation cost. Okay, and for the New Orleans, we have 1,200 cars, right? Whether we can fulfill in that Miami one, or whether we can use this 1,200 cars to fulfilling Denver market demand. That the decision we have to take it from the transportation problem. Okay, right. Now moving on, now we are going to create our Tableau. That is our transportation Tableau. Now this is a way you can create. Okay, now if you look at the previous one, there is nothing to do, right? Only we have to take those information into one table, right? This is again some kind of something like linear programming, right? Now these are your constraints. Now you can see, right? The supply, you have a constraint, the demand, you have a constraints. Okay, and what are your coefficient of the constraint? These are your transportation cost per one delivery. Okay, now for example, Los Angeles to Denver, for in your given case, you have to spend $80. Now it is appear in here, right? Now this is your coefficient, right? Normally we write the coefficient like this. Okay, so this is your transportation Tableau. Okay, now we have a question, how we are going to fulfill in this demand 2,300 by using these three supply sources. Okay, now the description says the transportation Tableau representation assuming that model is balanced. What we call model is balanced. Now if you add in these two sub demand 2,300 and 1,400, what we get? What we get as a total? We are getting as a total 3,700, right? Now if we add in this demand, what we get? The same, right? 3,700. Okay, so if our demand equal to supply, so demand and supply is equal, now we can see the total demand is 3,700. Total supply is also 3,700. Then demand and supply getting equal. So that kind of situation we call balanced transportation Tableau. This is a transportation Tableau where it's balanced. Why we call it as balance? Because demand and supply is balanced. Demand and supply is equal, right? So if the model is unbalanced, right? Why we call it is unbalanced? Normally in a practical situation, we know normally demand and supply are not getting equal, right? Sometimes market demand is higher than supply, or sometimes your supply is higher than market demand, right? If your demand higher than supply, or if your supply higher than demand, right? These two situations we call unbalanced. Okay. If your demand equal to supply, right, this kind of situation we call balance situation, right? This is the balance situation, right? This is a balance. If you unbalance mean your demand and supply getting unequal or it is not clear, it is not equal, right? If you're having that type of situation, what we can do is we have to balance our table. Otherwise, we cannot get a optimal solution, right? It is something like you try to measure something, then the two sides of your balance is not getting balance. අර අපි කියන්නේ තරාදිය දෙපැත්ත සමාන වෙන්න ඕනි කියලා. සමාන වුණාම තමයි අපිට හරියට උත්තරේ එන්නේ. දැන් මේ transportation tableau එක සමාන නොවුනොත් අපිට optimal solution එක හොයන්න බෑ. Therefore, we first of all make sure that demand and supply getting equal. If it is not equal, we have to incorporate dummy source, or we have to incorporate dummy supply column, or we have to incorporate dummy destination or dummy row, right? So row and supply you can decide, right, whether you have to take it as your demand side or take it as this as a supply side. It depends on you, right? It doesn't matter, but whatever you are taking, these figures need to be accurate. Okay, right. Now this is your tableau, and first case we are taking it as a balance case. Okay, now let's see what we can do with this as an optimal solution. Right. Now let's see this example. We make some modification, right? We discuss based on the unbalanced situation. Then you can get knowledge about the dummy source and dummy demand. Okay. Right. Now this is the example again we are taking. Now suppose that the capacity of one marketplace now increasing, now decreasing 1,300 cars instead of 1,500. Earlier it is 1,500. Now we reducing it to 1,300, right? Okay. So now the total supply equal 3,500 and our demand is still equal 3,700. Okay. It doesn't change, but the supply side we are making some slight amendment. Okay, now you can see the same example in here. Don't worry about these figures. Okay, but the middle figures don't look at right now. Just here you have supply from Los Angeles 1,000, from Detroit 1,300, New Oracle, New Orleans it is 1,200, and demand there is nothing changed. It is 2,300 and 1,400. Okay, now for the supply side you can see it is only 3,500, and but the demand side it is 3,700. Now we are having unbalance of 200, right? What we can do is we can increase, or we can include dummy supply row. In here we can include dummy supply row, right? So that is we call dummy plant. In your textbook it says dummy plant, so we call it in here, right? Now earlier we are having this coefficient value, that is our one route transportation cost from work phase to market. But when you add in this dummy, we don't have any transportation cost. We just only put it as an artificial value because we need to balance the table, right? Therefore, we don't have any values for these coefficients, right? අපි dummy එක දැම්ම මතක තියාගන්න ඒකේ transportation cost එකක් නැහැ, right? We just put it as an artificial value, right? So then we add this 2,200 in here and balance the tableau. Okay, because of the demand exceed the supply, the dummy plant we call dummy source with the capacity of 200 cars is adding to in order to balance the model. Now our model is balanced, right? I believe you are clear up to that point. Okay, now model is balanced, right? Now let's see how we are going to identify the optimal solution. Okay, how we find out what are the routes that we can fulfill in market demand by using the three warehouses supply at a minimum transportation cost. That is our objective. Okay, now the transportation problem, we can find out the basic solution. We call feasible solution, right? Please remember, first of all, we are finding feasible solution, not the optimal solution. So basic solution for the transportation problem can be identified using three methods, right? I'm repeating this again. So transportation, we have a transportation problem. What is the problem? Now we want to identify what would be the least transportation cost or minimum transportation cost that we can use to fulfill our market demand using 3 different supply sources. Okay, in order to find out the feasible solution or basic solution, we can work out with 3 basic methods, right? First method we call northwest corner method, and the second method we call least cost method. Okay, so northwest corner method, least cost method, and WAM method we call Vogel approximation method. In short, we call WAM method. Right? All these 3 methods are used to identify basic solution. Right? Therefore, don't confuse with the basic and optimal solution. First of all, we try to find out the basic solution. Right? So least west corner method mean the distribution started at the northwest corner method. So we start our distribution from the northwest corner of our table. Least cost method mean we started from the least cost, cheapest route. We find out the cheapest route first, and we start our distribution from that route. Vogel approximation method is little bit differ with that 2 method, right? Like northwest and least cost method. We in here find out the opportunity cost of the transportation. Right? We will discuss when we are coming out the workout plan, right? Okay, let's move into the first method we call northwest corner method. Right? Now, this is our tableau. Right? Now, this is our tableau, and this is not your previous example, right? This is different example, but you can apply the same thing once we discuss this one finish. Okay, now you are getting some tableau in here. This is balance approach. Okay, no any other dummy column or dummy row in here. Now you are having supply in here, and you are having demand in here. Okay, 3 supply sources, and you are having 4 demand. That means 4 marketplaces, and you try to fulfilling with 3 supply sources. Okay, now for the northwest corner method mean we are starting from this corner. Right, we are starting from this corner. Why we call northwest? That is our northwest. Right, this is north and this is west. This is north and this is our northwest. Right, දිසා මතක නැත්තම් නැවත මතක් කරගෙන බලන්න. හොඳේ? Right. Now this is our northwest corner. So in our tableau also this is our northwest corner. Right? So northwest corner we are starting from here, right? So in here you have to bear cost of 10. Assume that this is 10 rupee for one route, right? From supply, that means warehouse 1 to market 1. Right? You have to incur 10 rupees when we are providing or when we are supplying from warehouse 1 to market 1. Now, what is the supply of the warehouse 1? It is 15. And what is the requirement of the market? It is only 5, right? So then we can easily provide that market demand by using this warehouse supply. Okay, there may market එකෙන් ඉල්ලන්නේ unit 5යි. ඒතර මේ වෙලාවේ warehouse 1 එකෙන් produce කරන unit 15. ඒතර අපිට unit 15 use කරලා market 1 එකේ requirement එක fulfill කරන්න පුළුවන්. So therefore we include 5 in here. This is a very simple calculation. Okay, then there is no any other more market 1 to fulfill. There is no any other more demand in market 1 to fulfill. Then we can cut off this market. Then මේ market එක fulfill කරලා ඉවරයි. ආයෙ අපිට transport කරන්න දෙයක් ඒකේ නැහැ. Right? Then this demand is fulfilled. So you can remove that one. Then we have only this table. ඊට පස්සේ අපි ඉතුරුනේ මේ table එක විතරයි. We have only this table. Right? Now there is no one column. Right? There is no one column. Only column started from 2. That means we have now market 2 demand with 3 supply. And remember, we have already supplied this 15 out 5. Right? Out of this 15, we have already supplied 5. Then we have remained only 10. Don't forget about that supply amount. Right? ඒක අමතක කරන්න එපා නැත්නම් ඔයගොල්ලෝ හිතාගෙන ඉඳී මේක තාමත් 15යි කියලා. Right? Then look at this northwest corner again. Then it is here. Right? Your second distribution point. You are starting from here. Then you have only 10 supply of unit and market requirement is 15. right? Then you provide this 10 in here. Okay, then you can see the supply of the warehouse 1 is already finished. The supply එක market warehouse 1 එකෙත් ඉවරයි. ඊට වඩා යාර දෙන්න බෑ. Right? 5 is given for the market 1 and 10 is given to the market 2 demand. Now, market 2 demand, you have to reduce this 10. Right? Now you have another 5 to fulfill. Okay. Now your tableau, your table, you don't have this first row as well as first column in your table. දැන් මේ table එකේ ආයෙ ඔයාට first row එකකුත් නැහැ, first column එකකුත් නැහැ. Right? Then you are starting from this cell. That this cell means second column, second row. Right? Then you are starting from here. You started first here, then you go second here, then this is your third place. Okay, this is your third place. Right? Then you have only 5 market demand to fulfill. Right? You have only 5 market demand to fulfill. You provide that 5 into here. Okay, that means using this 25, you can supply that 5 into here. Then this 5 is also take it off, right? Then that column also you can remove. Then remove this 5 in here. You have remain 20. Okay, you have remain 20. Right? Then again, starting point is northwest corner is here. It is 4, right? So you have to fulfill 15 in market 3. Now you can directly supply, you can directly provide it by using this 20. Then again you have to remove this 15 in here. Then you have remain with 5 in warehouse 2, right? Then you can remove this one also, right? The remaining in here, then you have to provide that 5 into here and 10. You don't have any other option. You have to provide that market 4 demand by using warehouse 3 supply. Then this 10 is also set off. Then this is, since this is a balance situation, you can easily do it and then finally calculate the total transportation cost. How to calculate? So you have to provide 5 in here. That means you have to go 5 times in here. Then 5 into 10, that because we are giving only one route cost, right? You have to provide 5 times in here, right? 5 into 10 and 10 into 2, right? Likewise, calculate all the things, right? 5 into 7 and 9 into 5, 9 into, where is it? Yes, 15 into 9 and 20 into 5 and finally 10 into 18. Altogether, you are getting total transportation cost as $520 by using northwest corner method. Okay, by using northwest corner method, you come across with the total cost of transportation with $520. Okay, right. So that is the first method. Very simple method, starting from northwest corner and cut off with the fulfilling market demand or your supply and continue as a step until all your market demand and market supply getting equal. Okay, right. Let's move into the second method we call least cost method. Okay, so that is the second method. Actually, the word give mean to you, least cost. You are starting from least cost point. That means your least transportation cost from one place to another, you have to start from that point. Right? So based on this tableau, forget about this middle part. Based on this tableau, what we can see about this transportation cost? Now we can see 2 is the least cost. All other things are higher than 2, right? 2 is the least cost. Then you try to fulfill in the market demand 2. You try to fulfill in the market demand 2 by using warehouse supply 1. Warehouse 1 supply. Right? So warehouse supply 15 units. Right? It supply 15 units and market demand also 15. So we can set off this demand and supply. Then you can start with the market 2 demand fulfillment using warehouse 1 supply. Then you can set off this row, sorry, this column number 2 as well as row number 1. Right? Now let's see the remain. Right? Now we have these things. Right? After removing this thing, you have column number 1, column number 3, column number 4, along with row number 2 and row number 3. Then after looking the remaining things, you can see that 4 is the least cost. Okay, Then you are coming to this point. Then you start your distribution from warehouse tree to market 1. Sorry, yes, warehouse tree to market 1. Then you supply 5. Then your market 1 demand supply fulfill, right? Then remain 5 is here. Okay, because warehouse tree supply 10 units. Out of 10, you provide 5. Then you have remaining 5. Okay. So that's the thing we have to work out, right? Then this supply is all, sorry, this market is also fulfilled, right? Then again, looking at what is the least cost. Again, looking at what is the least cost. Okay, then it is 9. Yeah, right? There is no any other least cost, it is 9. Then you have to fulfill this market tree demand, that is 15, by using sub warehouse 2. Right? Then you have to supply this 15 out of this 25. Then you can remove that 15 in here. Then you ended up with 10 unit of the warehouse 2. Then this market demand is already completed. Then you have remain only this. Out of this column, you have 11 as a least cost. Then started from here, but you don't have anything to supply because this is already finished. Right? That make already finished. Then you are coming to the next least cost. It is your 18, right? Then you supply that 5. Okay. Then out of 5, then you have another 10 to fulfill. That 10 you are ended up with this warehouse 2 by spending $20 per route. Okay. Now that is the way you are calculating least cost method. Right, least cost method. Now, after making this road plan, you can calculate your transportation cost. Then you ended up with $475. Right. So if you go back to your previous one, okay, if you go back to your previous one, you can see that for the northwest corner method, your total transportation cost is $520. Now, when you are using the least cost method, it reduced to $475. Now you can see each method give different approaches. Okay. Now this one we are starting from in here, but this one we are starting from here. Okay. Right. Now we are moving to the third method. Right. We are moving to the third method we call Vogel approximation method.